Today we're on pages 303 and 304 of our textbook, Lesson 11, Multiplying and Dividing Rational Expressions. Exercise number 1, we want to simplify each of the following products. We want to use the rules of exponents to simplify monomial numerators and denominators. We have this 8y to the 7th divided by 5x to the 3rd times 10x to the 2nd divided by 6y to the 3rd. So we're multiplying these two rational expressions here. So I would go with, form a habit, start with the coefficients. 8 and 6. 2 divides evenly into each. 2 goes into 8 4 times, 2 into 6 3 times. The 5 and the 10. 5 goes into 5 once, 5 into 10 twice. The y to the 7th and the y to the 3rd in a denominator. We subtract exponents. We have 7 minus 3, which would be a y to the 4th, which is the same as it would leave us with a y to the 4th here in the numerator. Now the x's, the x squared in the numerator and the x to the 3rd in the denominator, the x squared in the numerator would divide out with 2 of the 3 x's in the denominator, leaving a single x in the denominator. Let's see, what do we have? We have 4 times 2, which is 8, y to the 4th in our numerator, and 1 times x times 3, which is 3x as a denominator. And this cannot be simplified further. Let's go with B. Now, I also realize that there are some of you that you would prefer to just multiply straight across, which you can do. All right, let me just go back to A. And if I was to multiply straight across and get 80 x squared y to the 7th over 30 x to the 3rd y to the 3rd, I could do that. And then reduce now, 80 and 30 is 8/3, dividing each by 10. X squared divided by x to the 3rd, if I subtract the exponents, gives me x to the negative 1. And y to the 7th divided by y to the 3rd would be y to the 4th. And the only thing, let's just take this x to the negative 1 and put it down into the denominator. So we have 8y to the 4th over 3x. So we'll end up with the same result, of course, but it can be found out differently, that's all. Okay, so if you want to do that, and maybe you do, in fact, I'll take this one and do that. I'll multiply across. That's 60 times 3 is 180. X squared times x is x to the 4th. Y to the 3rd times y to the 2nd times y to the 1st is y to the 6th. I'm going to do 4 times 5 is 20 times 9 is 180. Oh, that's nice. No. Yeah, that's right. X to the 5th times x to the 5th is x to the 10th. And y to the 2nd times y to the 7th is y to the 9th. X to the 4th divided by x to the 10th is x to the negative 6th. And y to the 6th divided by y to the 9th is y to the negative 3. And I want to express this as a rational expression. So I don't want my negative exponents, rather let's throw them into the denominator with positive exponents. So we have 1 over x to the 6th, y to the 3rd. And or I could have gone with some of my dividing out, like I go 5 into 10, 3 into 9. It's your preference. I'm not going to continue with that. That is the answer. Okay, so multiplication of rational expressions follows the same principles as those involved in simplifying them. That is, factor completely Then divide out common factors. So you factor the numerator, you factor the denominator, and then divide out common factors. And these common factors are to a numerator and denominator. Simplify each of the following. All right. We have this times this. Factor this numerator, the difference of perfect squares, x plus 2 times x minus 2. Factor this denominator, the factors of negative 6 that sum to negative 1 are negative 3 and 2. Times, make sure you write down the operator, multiplication. This denominator, 3x is a GCF that comes out, x plus 5 in parentheses. And this denominator, excuse me, I think I might have mentioned this denominator, this numerator, 3x comes out. Now this denominator, 6x is a GCF, x minus 2. Now, the x plus 2, so numerator, denominator, divide out. The x minus 2, numerator, denominator, divide out. The x divides out. The 3 and the 6 reduce, 1 and 2. Our answer is, our numerator is x plus 5. Our denominator, we have 2 times x minus 3. And the 2 times x minus 3 can be left in this factored form. You do not have to distribute the 2 over the parentheses. This is our answer. For B, and it's multiplication, so we're going to factor the first numerator, GCF of 2x. Factor the denominator, GCF 4, times, factoring the trinomial numerator, factors of negative 12 that sum to negative 4 are negative 6 and positive 2. And the denominator here is the difference of perfect squares, x plus 6 times x minus 6. The x plus 6's divide out, x minus 6's divide out, the x plus 2's divide out, the 2 and the 4 reduce. Our answer is x over 2. Just keep in mind, if everything divided out, the answer would be 1, not 0, but 1. Okay, C, factoring the numerator. Difference of perfect squares, 3 plus x times 3 minus x. Denominator has a GCF of 2x squared. X minus 3 times numerator GCF 4x. And the denominator, factors of negative 3 that sum to 2 are 3 and negative 1. Okay. The x minus 1's divide out. 3 plus x and x plus 3 are exactly the same, just written in a different order. Positive x, positive 3, positive x, positive 3. They divide out. Now, the 3 minus x and the x minus 3 are opposites. Positive 3, negative x, negative 3. So these are opposites. They are going to divide out, but I'm going to replace with a negative 1, because they're 2 and the 4 reduce, and this x will divide out with one of these 2, leaving an x down in the denominator there. Looking across the numerator, we have -1 times 2 is -2. The denominator, we have simply x, so -2 over x. So with multiplication, again, you're just going to factor numerator, factor denominators, divide out common factors. Next, division. Division by a fraction can always be thought of in terms of multiplying by its reciprocal, right? Just keep in mind, way back in grade school, if you had 1/2 divided by 6/11, you would keep the first fraction, 1/2 times, and keep change, flip, and flip the second fraction. Nothing divides out there, we'd have 11/12. Right? Keep change, flip. But we don't use that, not at the Algebra 2 level. We say we multiply by the reciprocal. All right, so A, 15x squared over 6y to the 5th divided by 5x to the 8th divided over 2y to the 7th. We are going to keep the first fraction, 15x squared over 6y to the 5th, change division to multiplication, and let's write the reciprocal of our second fraction here. Now we have a multiplication problem, so now we proceed as if we're multiplying, in which case I'm going to reduce. The 5 goes into 15 3 times. Some of you prefer to just multiply across, numerator and denominator, and then simplify. Let's see, 2 into 6 3 times. These 3's divide out. Y to the 5th into the y to the 7th leaves us a y to the 2nd here. And x to the 2nd divides out with 2 of those 8, leaving with an x to the 6th. Numerator, we have a y squared, and denominator, 3x to the 6th. No, sorry, just x to the 6th. So y squared over x to the 6th. B, we have division, which we are going to change to multiplication, and write the reciprocal of the second fraction. The 30 and 20 each dividing by 10, and then the 8 and 24 each dividing by 8, and then those 3's divide right out. Y to the 2nd, y to the 6th, y to the 4th in the numerator, the x, x to the 3rd, x to the 2nd in the denominator. Numerator looks like we have a y to the 4th. Denominator, 2x squared. I think it's actually easy. So this is where our numerator and denominators were monomials, single terms. I think it's actually easier when we have polynomials for our numerator and denominator. Okay, we keep the first fraction, copy that down, times the reciprocal, so 2x plus 10 over x squared minus 16. Now we factor. Factors of -8, that sum to +2, +4, -2. GCF 8, x minus 2, times GCF 2, x plus 5, and difference of perfect squares. factoring skills are very, very important here. X plus 4's divide out, the x minus 2's divide out, the 2 into 8 4 times. Our answer is x plus 5 over 4 times x minus 4. D. Okay. Instead of rewriting, just to save a little bit of time and space, I'm going to start with factoring the first one. 3x plus 1 times 3x minus 1 for the numerator. That's the difference of perfect squares. Now the denominator, to factor that, gotta do the rainbow. That's 6. The factors of 6, that's sum to 7. 6 and 1, so 3x squared plus 6x plus 1x plus 2. Split. Get 3x, x plus 2, and 1, x plus 2. Right, so x plus 2 and 3x plus 1 are our factors for our denominator. Change division to multiplication. Now I want the reciprocal, okay? So the factors of the numerator here, taking out 5, belong in the denominator. Okay. Minus 3x. And then my numerator here is going to be factors of this denominator. Negative 7 and 2. Dividing out common factors, the x plus 2's divide out, 3x plus 1. The 3x minus 1 and the 1 minus 3x, these are opposites. Okay, these are opposites. So I'll replace them. They'll divide out and be equivalent to negative 1. So we have here in our numerator negative parentheses x minus 7, and our denominator is 5. Realize that the negative could be placed in the denominator, or the negative could be out in front of the fraction. These are all equivalent. I might as well throw in here, if we distribute the negative in the numerator, we would get negative x plus 7. So these are all equivalent. Okay, and lastly, when x squared minus 25 over 3x is divided by x plus 5 over 9x, what's the result? Okay, so we're going to take this, let's write it in its factored form. Difference of perfect squares times 9x, and now be the numerator because we're taking the reciprocal, and dividing out common factors. Plus 5, 3 into 9 3 times. So we have 3 times x minus 5, which is the same as 3x minus 15. Choice 2. Thank you very much for your attention.